There is a planet in our solar system that has been deceiving us for centuries. We have photographed it thousands of times. We have turned it into the visual symbol of the cosmos, the favorite of children learning astronomy, the planet everyone recognizes at a glance. With its perfect rings, its soft golden color, its majestic presence in the night sky, Saturn looks like the most serene place in the universe. But that image is a lie. Not an exaggeration, not a simplification, a physical, concrete, verifiable lie. Because what we see from Earth, what telescopes capture, what hangs framed on classroom walls, is the surface of a deception. Beneath those rings and those golden clouds exists one of the most violent, most extreme, and most life-incompatible environments in the entire solar system. And today, we are going to descend into it, layer by layer. Let's start with scale, because without understanding scale, nothing that comes next will land the way it deserves. Saturn has a diameter of approximately 116,000 kilometers at its equator. That means you could line up 9 Earths side by side across that diameter. But the volume is even more disorienting. Roughly 764 Earths would fit inside Saturn. This is not a normal difference in scale. It is a difference that the human brain simply was not built to process intuitively. And yet, despite that monstrous size, Saturn is the least dense planet in the solar system. Its average density is 0.69 grams per cubic centimeter. Water has a density of 1. That means that, in theory, if an ocean large enough existed, Saturn would float. A planet 764 times more voluminous than Earth, floating like a cork. But that elegant fact carries a consequence that completely changes how we should think about this planet. If Saturn is so low in density, it is because it is made almost entirely of gas. Hydrogen and helium primarily. No rock, no ground, no solid surface to land on. If tomorrow we sent a spacecraft towards Saturn with instructions to land, it would not land. It would simply begin to sink. To fall into the planet's interior with nothing to stop it, while the pressure surrounding it increased exponentially, destroying it long before reaching any core. There is no landing on Saturn. There is only descent. And in this case, descent is a death sentence. If you still think Saturn looks peaceful, subscribe, because what comes next might change that permanently. And before we continue, did you ever think of Saturn as a dangerous place? Or has it always seemed like the most serene planet in the solar system? Leave it in the comments. The winds in Saturn's upper atmosphere reach speeds of up to 1,800 kilometers per hour. To put that in perspective, the most powerful hurricane ever recorded on Earth, a Category 5 at its most destructive, produces winds of between 250 and 300 kilometers per hour. Saturn's winds are 6 times faster than that. These are not gusts, not localized storms. They are permanent, constant winds that wrap the entire planet in horizontal bands of destruction that have been active for thousands of years. On Earth, a wind moving at that speed would tear mountains apart. On Saturn, it is simply normal weather. We used to think Saturn's atmosphere was relatively stable, at least compared to Jupiter and its Great Red Spot. But the evidence contradicts that assumption in dramatic fashion. Roughly every 30 Earth years, Saturn experiences what scientists call a great white spot, a planetary-scale storm that does not affect a single region, but instead expands until it encircles the entire planet in a band of atmospheric chaos. The most recent one occurred in 2010 and 2011, observed both from Earth and by the Cassini spacecraft, which was orbiting Saturn at the time. The storm generated lightning whose electrical power was 10,000 times greater than any lightning bolt on Earth, and it lasted for months. A global storm that lasts for months, with lightning 10,000 times more powerful than ours. But there is something on Saturn that has puzzled scientists for decades, more than any storm. Something that should not exist according to any atmospheric model we know. And it has the shape of a hexagon. At Saturn's North Pole, there is a permanent atmospheric structure with the shape of a perfect hexagon. Each side of that hexagon measures approximately 14,500 kilometers, meaning nearly 2 Earths would fit inside it. It has been active at least since the Voyager probes photographed it in the 1980s, and, most likely, for far longer before that. At the center of that hexagon sits a polar vortex, a permanent circular storm with a clean, well-defined eye like that of a terrestrial hurricane, but on dimensions that would make any storm on our planet look irrelevant. Atmospheric models can reproduce similar hexagons in laboratory settings under certain conditions of rotation and velocity differentials. But explaining why that shape remains stable for decades on a planet with no solid surface to anchor. It remains one of the open problems in planetary science. But the winds, the storms, and even the hexagon are only the surface of the problem. Something is waiting in the deeper layers of Saturn that no scientific model predicted, and it completely changes the way we understand this planet. Before we get there, Saturn also emits radio waves. Before we go there, 2 questions. Do you think the polar hexagon has a purely physical explanation? Or is there something current models still cannot capture? And does it unsettle you that a geometric structure of that size can maintain its shape for decades on a planet made entirely of gas? Leave your thoughts in the comments. Saturn's radio emissions are linked to its magnetic field and to the interactions between its moons and its rings, particularly with the moon Enceladus. And that mention of Enceladus deserves a moment because it contains one of the greatest paradoxes in our entire solar system. Enceladus is a small moon, barely 500 kilometers in diameter, orbiting in the shadow of Saturn's rings. And yet, beneath its frozen surface, it harbors a global liquid water ocean. Its south pole vents geysers of water vapor and organic molecules into space, which Cassini flew through and sampled directly. Saturn itself is one of the most hostile environments imaginable, but one of its own moons may be among the most promising places in the solar system to look for life. The monster and the cradle orbiting together. Hold on to that image, because soon you will understand why those radio emissions are a clue to something happening deep inside Saturn, something nobody expected to find there. The descent into Saturn's interior begins in the upper layers of gaseous hydrogen. Pressure is low, temperatures are extremely cold, and winds dominate everything. But as we go deeper, something begins to change. Pressure increases, temperature rises, and hydrogen, which at the surface behaves like a normal gas, starts acting differently. At a depth of several thousand kilometers, the pressure is so extreme that gaseous hydrogen transforms into liquid hydrogen. There is no sharp transition, no clear line to cross. It is a gradual, continuous change in which the gas simply stops being a gas without anyone being able to point to exactly when it happened. And that is already strange enough, but it is not the strangest part. We keep descending, pressure keeps building, and we reach a point where even liquid hydrogen is not dense enough for what the planet demands. This is where Saturn stops being a planet and starts being something else entirely. At pressures of millions of atmospheres, hydrogen undergoes a transition that has no equivalent in any laboratory on Earth under ordinary conditions. It becomes metallic hydrogen, a state of matter in which hydrogen's electrons break free from their atoms and begin to flow freely, exactly as they do in metals. The result is a material that conducts electricity extraordinarily well. And it is precisely that vast layer of metallic hydrogen rotating inside Saturn that generates its magnetic field, and that produces the radio emissions we mentioned earlier. That was the clue. At the core, temperature is estimated between 11,000 and 15,000 degrees Celsius. Pressure reaches several million atmospheres, and there is something scientists have known for decades, but that rarely makes it into mainstream science communication. Saturn emits more heat than it receives from the Sun. A planet that generates its own heat, that sustains itself from within. The implications of that are stranger than they first appear. Saturn generates heat internally, most likely through a process in which helium condenses and rains down toward the planet's interior, releasing gravitational energy as it falls. The spacecraft that taught us most of what we know about all of this was Cassini. It orbited Saturn for 13 years, crossed its ring plane dozens of times, sampled Enceladus's geysers, and mapped the Hexagon in extraordinary detail. But in September 2017, mission controllers at NASA made a deliberate decision. They guided Cassini directly into Saturn's atmosphere, not as a failure, as a choice. The probe was intentionally destroyed to prevent any risk of contaminating Enceladus or Titan with Earth microbes. Even the machine that knew Saturn best was ultimately consumed by it. There is something quietly devastating about that. Wait, let's step back for a second. Everything we've covered so far, the winds, the storms, the Hexagon, Cassini, has been the atmosphere, the outside. What's happening on the surface of something that has no surface? But we haven't gone in yet, and what's inside is where Saturn stops being strange and starts being something else entirely. In the layers of Saturn's atmosphere, methane can break down under extreme pressure and temperature, releasing carbon atoms. Those carbon atoms, subjected to increasing pressure as they fall, can compress into graphite. And graphite, under even greater pressure, can become something more. Diamonds. Millions of tons of diamonds forming inside Saturn, falling toward the core in a constant, silent rain. Models suggest that as much as 10 million tons of diamonds may form each year. Diamonds the size of grains of sand, or possibly larger, falling through layers of liquid hydrogen toward the planet's depths. But the story does not end there. Because when those diamonds reach the deepest layers, where temperatures exceed thousands of degrees, something seemingly contradictory happens. The diamonds melt. They dissolve. And what remains is not solid diamonds. but oceans of liquid carbon deep inside the planet. An ocean of molten diamonds inside Saturn. It is the kind of phenomenon that reminds us that the physics of the universe does not need our approval to do whatever it wants. But there is still one more thing to see, something that rarely appears in descriptions of Saturn, and that completely changes what it would feel like to be near this planet, even in imagination. Saturn's rings are its most iconic feature, but they carry a consequence that no one anticipates. They cast shadows, enormous shadows that block sunlight over entire regions of the atmosphere. And because of Saturn's axial tilt, those shadows shift with the seasons. There are periods when certain bands of the planet remain in partial darkness for consecutive Earth years. Not days, not weeks, years. The moons orbiting within the shadow zones of the rings experience radical temperature swings. Saturn's own atmosphere responds to those shadows with changes in its chemistry and circulation patterns. The rings are not just decoration. They are an active element that shapes the behavior of the planet itself. And this is where it is worth pausing and letting everything settle. Saturn contains hydrogen that behaves like metal. Diamonds rain silently through its interior and melt into liquid carbon oceans. One of its moons may harbor life. Its rings cast shadows that last for years. None of that was designed for us to understand easily. None of it was designed for us at all. Saturn is not peaceful. It never was. It was just far enough away to look that way. Saturn is not the peaceful planet you learned about in school. It's metallic hydrogen, diamonds raining down and melting into liquid oceans, storms that last for years, and a moon that might harbor life while orbiting one of the most hostile places in the solar system. If this video shifted even slightly the way you look at that golden dot in the night sky, hit the like button. It helps more than you'd think. And if you're not subscribed yet, now is a good time, because there are plenty more planets out there that aren't what they seem. And here's the question I want to leave you with. If you could send a probe anywhere in the Saturn system, where would you send it? And what would you be looking for? Enceladus, Titan, inside the Hexagon? Let me know in the comments.